Hello, good evening to all of you. I hope all you are doing well. Guys, today are we going to study about that is alternating current, right? We are going to revise our alternating current topic, and basically we have already completed our electromagnetic section till alternating current. So today we are basically revise the concept through some PYQ. That PYQ are basically asked in previous J and NEET section, right? Guys, let us start the class. Before come to the problem, firstly I would like to tell you some basic concept and some basic formula that is related to alternating current. So if we talk about the guys, firstly, what is the alternating current? I hope you are know about the alternating current. If we talk about the alternating current, we can say that the current which is the function of the time, that is the vary with the time. This type of current or this type of voltage that is known as the alternating current or alternating voltage, right? So here some basic terminology I would like to discuss here. If we say that keep any voltage or current is function like this, that V equal to sine omega t plus phi. So we can say that this is the basic equation of sinusoidal wave, right? It means we can say that this is the equation that is the voltage performing either the function of sine, either the function of the cos. So in combinedly, we can say basically this type of function is known as the sinusoidal function. Here, if we talk about the what is the V naught, what is the V naught, right? So if we talk about the V naught, guys, so what is the V naught? So if we talk about V naught is known as peak voltage. V naught is known as peak voltage, right? V naught is known as the peak voltage. Omega is nothing but our angular frequency, and that is also written as 2 pi f. And phi is known as the initial phase. Phi is known as the initial phase, right? So here, if we talk about Kisser, if we want to write down any equation in alternating current, the all the equation that is come in this manner, basically which is the function of the sine and cos, and the peak voltage is also known as the maximum voltage. This voltage is also known as the maximum voltage, right? So here, so what we can say that ki phi is our initial phase. So we not is the peak voltage or maximum voltage. I am not too much interested to find out the value of the peak voltage. Basically, in the alternating current, the most important value where we are dealing generally RMS value. So we are talking about and we have to find out VRMS. That is the root mean square value of the voltage. For the sinusoidal case, root mean square value is written as maximum voltage divided over root 2. These are the some basic terms. And one is, if we are talking about, there is the some type of terminology related to alternating current. That is the one is the peak voltage, RMS voltage. Another is the that is the word reactance, right? What is the reactance? Actually, reactance is just similar nature to resistance, and reactance word is used for the inductance and capacitance, right? We can say that the inductance and capacitance are the passive element of the circuit. So there are two types of reactance. One is known as inductive reactance. One is the inductive and another is known as capacitive reactance. That is the capacitive. Inductive reactance that is represented by XL and capacitive reactance is represented by XC. We are already aware about the resistance. We know the resistance is represented by R. So there are two types of inductance. When we are talking about inductive reactance, that XL is always written as omega into L and XC is always written as 1 upon omega C. So here what we observe that the XL this is and omega is written as 2 pi FL where F is the linear frequency and L is inductance of the circuit. See the capacitance of the circuit. So we can say if we put the value of omega that is the 2 pi FC. Correct? Here, one thing we have to observe that XL and frequency of the any AC circuit that having a linear relationship. Sometimes it is directly asked what is the graph between XL and F? We can say straight line passing through origin, right? Here, if you want to draw the graph between the XC and F, we can say the XC is inversely proportional to frequency of the circuit, that is the rectangular hyperbola. I hope this is clear. Correct? So we can say that in this manner XL and XC are related. And if any circuit, all the elements are present, that is the resistance and both the reactance, we can say that in this case, the net resistance of the circuit is known as, that is the another term that is known as the impedance. Guys, impedance is represented by letter Z, and this impedance is written something like vector, not exactly vector, but something like vector. In the pure real axis, horizontal axis, we represent our resistance, and in vertical axis, that in the case of alternating current, we can say that in the imaginary axis, we represent XL and XC. As we know that our XL is greater in phase as compared to resistance. So this is our XL and this is our XC. Whatever greater in magnitude XL and XC, depending upon their magnitude, we can say that this circuit can be also simplified in this manner. That is the magnitude of XL minus XC, and the resultant can be find out like as a hypotenuse and apply the Pythagoras. We can say this is our Z, right? So we can say our Z is written here, that is under root of R square plus XL minus XC whole square. One thing I also want to mention here, what is the phase? Actually, when we talk about the pure resistive circuit, we can say कि phase of current and phase of voltage is same. So here, that is consider one case. If pure resistive circuit, we can say voltage and current in same phase. This is the case of pure resistive circuit. When we are talking about the pure resistive circuit, so we can say in this case this will happen. Whenever we talk about that is the pure inductive circuit, that is second case, pure inductive circuit. What will happen in the pure inductive circuit? The voltage is leading with current by 90 degree. So how we can write down the phase difference? See here, we see that the voltage across inductor is greater than 90 degree. So we can say this is our phase of current or this is our phase of resistance, right? So we can say this phi is 90 degree. In the same case, we talk about the pure capacitive circuit. Pure capacitive circuit. So in this case, what will happen? Current is lead. We can say if this is the horizontal axis, that is the pure real axis, and this is the VR also, I also. So we can say in this case, what is happening here? Guys, we can say that in this case, current is leading in phase. We can say if current is leading in phase, we can say this is the our current. So we can say current is leading by 90 degree in phase, right? So here a question that is come that has come in CBSE AIPMT 1996. What is given in the problem? In an experiment, 200 volt AC is applied at the end of LCR circuit. Guys, that is very easy topic, and if you are going to apply whatever basic you have to learn, you can definitely solve the problem. 100% sure you can solve any type of alternating problem, and just depend upon the one formula. Okay, just follow the process. Whatever we have to apply the given concept, just see how we can solve the PYQ problems. So here one thing is given, that series LCR circuit. LCR circuit. So we can say that all the elements are present here. One information that is given here. What is given here, guys? It is given here that voltage is 200 volt. So we can say if we represent the circuit, this is our resistance, this is our inductor, and this is our capacitor, right? And all three elements are connected with the AC source. So we can represent our diagram in this manner. And here the voltage is given that V equal to V naught sine omega t. This is the standard format of the varying voltage, that is the AC voltage. And here it is given that the voltage, that is the peak voltage, that is given to 200 volt, right? Okay. The another information is given here, inductive reactance. Always check with the unit also which quantity is given. That ohm, so we can say this is the inductance. We can say XL is given here, and the value of XL is given. Value of XC is also given. So we can say this is the value of XC, and value of resistance is also given. Correct? In this problem, it is asked about the Z. So we can say that R is given, that is the 10 ohm. XL is given, that is the 50 ohm. XC is given, that is again 50 ohm. So if you want to find out the value of Z, we can say that, and we also know that Z can be written in this manner, that R square plus XL minus XC whole square. Put this value and get the answer. So we can say XL and XC is equal to each other. This value will become that 50 minus 50 whole square and Z is equal to R, right? So we can say that our impedance is equal to 10 ohm. So we can say that option A is the correct answer, and we can say that is a very easy problem, and there are a lot of conclusion from this problem. We can learn a lot of things from this problem. What we can learn, and in the problem it is given that XL equal to XC. Whenever XL equal to XC, we can say if XL is given than XC, so this is the condition of the resonance. This is in series LCR circuit. Whenever XL is given than equal to XC, we can say this is the resonance condition. What will happen in the resonance condition? We can say if we put the value of XL, this is the omega L, this is the 1 upon omega C. Omega which can be written as root over LC. If we put the value of omega further here, 2 pi F. So whenever it is asked about problem, find the resonant frequency. So we can say we can apply this formula 1 upon 2 pi root over LC, and that is the again very important formula. Correct, hai? Right? So let's move further next problem. In the next problem, again it is given that an LCR circuit is connected to a source of alternating current, correct, at resonance. Check the problem and read the question very carefully. Whenever it is asked in the problem that condition of resonance, if information is given about to resonance, so then write down all the information, whatever you know about what is going to be happen in the resonance condition, right? So guys, in this question, what we can say ki that this is the series LCR circuit. Okay, so if we know that ki what is the condition of resonance, so if we draw the series LCR, this is the L, C, and this is the R, correct? And these all three are connected with the AC source. The voltage across inductor is VL, voltage across capacitor is VC, and voltage across resistor is VR. Say resistance of circuit is R. This is the reactance across capacitor XC, and this is the XL. Right. If it is asked or it is given in the problem that condition of resonance, I am not going to solve this problem, but I would like to explain all small trigger points that is related to that problems and what is the learning outcomes of this problem. Correct? So if we talk about the what is the condition of resonance, whenever it is given that VL equal to VC, first condition. If we write down in this manner I into XL, I into XC, so we can again write down XL equal to XC. This is the first condition. This is again written in another manner. If we write down here what is the resonant frequency, so this can be written as previous slide. Also, I found that F is nothing but 1 over root 2 pi root over LC. Correct. And if we talk about what is our impedance, we can say Z equal to nothing but under root R square plus XL minus XC whole square. But XL and XC to equal to each other, we can say Z is equal to R. That is the very important concept. Z is equal to R. So what we can say that whatever total impedance of the circuit that will equal to resistance of the circuit, we can say that this is behaving like this. If only a resistor is connected to this circuit, we can say that circuit will become pure resistive circuit. This circuit will become pure resistive. Correct? Pure resistive circuit. Our circuit will behaving like pure resistive circuit. What is the another information? If we talk about the power factor, what is the power factor? We know that the power factor is written as cos phi, right? And cos phi written as R by Z. So we can say that R and Z are equal to each other. So power factor will become equal to 1. In this case, value of power factor is equal to 1. And what is another information, guys? If we want to write down here, guys, what is the power, that is the average power in AC circuit. So we can write down the average power VRMS, IRMS, cos phi. If phi cos phi equal to 1, so we can say another thing here, that is cos phi equal to 1, phi is equal to 0 degree. Phase difference is 0 degree here. So what is the average power? Because the circuit is behaving like a simple DC circuit, because the element which having the fluctuation of frequency, that is eliminated from the circuit. So this power can be written just similar to simple DC power, that V into I. So this can be written as V RMS and I RMS. Correct? So this is our average power. This is our average power. So this is all about whenever it is asked in the problem that is the condition of resonance. So we have to think about all these points. We have to must keep in mind all these points, and every year, if I am talking about every year, either context of JEE Main and NEET, if question will come under the alternating current topic, so there is the 90% probability the question will form in the section of resonance. So I think you can understand what is the importance of this topic. If we would like to solve this given problem, so we can easily solve. In this problem, it is said that at resonance, the applied voltage and current flow through the circuit have a phase difference. If it is asked about the resonance, so we can say phase difference is nothing but 0 degree. So answer is 0 degree. So I hope you can understand how easily we can solve problem if we know the condition of the resonance. Guys, note down all these things. These are the very, very important and helpful for solving the alternating problems. Okay. In the next problem, that question is again come in the CBSE AIPMT, right? That is now known as NEET. Coil of inductive reactance. Very good. Inductive reactance, it means we can say if you want to solve this problem, so that is XL is given, that is the 31 ohm, and resistance, that is R is 8 ohm, right? It is placed in series with a condenser of the capacitive reactance, that is XC is given like 25 ohm. Already is asked in the problem, it is connected in series, so we can say that this is our inductor, this is our resistor, and this is our capacitor. All three are connected in series via alternating source, and the AC source having the voltage of 110 volt. So here the voltage is given. We know the fluctuating voltage is always given in this manner, right? Here AC source voltage is given that 110 volt. Power factor, in this question power factor is asked. So we have to think what is the power factor? What is the power factor? Right, guys? So when we have to think about the power factor, when nothing is mentioned in the problem and the suppose voltage is given, then we have to think if this voltage is the RMS voltage. Correct. So here, what is the power factor? If we are talking about the power factor, so power factor is written as cos phi, and cos phi is written as R upon Z. Correct. So here R is given, we have to calculate the impedance, and impedance is find out with the help of impedance triangle. This is our R, XL and XC. We can say what is the net difference of XL and XC, that is again 31 minus 25, 8 ohm. This is also 8 ohm. This is our XL minus XC. We can say this is our Z, and the value of Z is nothing but 8 root 2. If we talk about this angle, so this angle will become, that is the 45 degree. Right. So here we can say that what is this value? Z can be written as simply R square plus XL minus XC whole square, and the value of R is, that is the 8, and this will also become 8. 8 square, 8 square. So this will become 8 root 2. So here value of the power factor, that is the cos phi, this will equal to 8 upon 8 root 2. So this will become, if we solve this value, 1 upon root 2. So this is the value of the power factor, that is 1 by root 2. If you want to solve this value, this can be written as 1 upon root 2. So this can be written as root 2 by 2. So this can be written as 1.414 by 2. So here, if we divide this value, we can say that if this value is, we can get the, what is the answer here. Put the root 2, if you solve this, so this will become 0.7. 0.7, we can say that is the approximately equal to 0.80. That data is closer to 0.80. If you divide these terms, we can say that this value something like that, 0.75. So in this manner, we can solve any type of problem, right? Just move further this problem. Just what is given here. Some important thing I also want to mention here, whenever we have to calculate, suppose resistance is given and we know the value of R, we know the value of current, then we can write down the voltage across the resistor, that I into R. Suppose this is our capacitor and we know the value of XC, and we also know the value of current that is flowing in the inductor. We can say, we can also write down the voltage across the capacitor, that is the I into XC. In similar manner, if we say that we know this is our XL current, we know, so we can also write down here VL, that I into XL. Correct. So here, if we series LCR circuit is given, suppose if series LCR circuit is given here, this is our series LCR circuit, this is our R, XL and XC, right? So we can say V net, this can be written as under root, that is VR square, VL minus VC whole square. That is just similar to something like this. That is the triangle of impedance triangle. We just similar to, we can write down this is our horizontal or real axis. In this axis, we can represent VR, because we know that key voltage and current, that is the same phase in case of the pure resistive circuit, and we know the phase of the voltage across inductor, that greater than 90 degree in phase as compared to current. And here is our VC. So we can write down the V net in this manner. Our V net is also write down something like as a vector VL minus VC. So this is nothing but our V net, right? And this angle is known as the phase angle. So whenever any type of problem that is asked in the LCR circuit, we can approach the problem in this manner, right? And whenever the omega is given, we can also write down the 2 pi f. XL is given as omega into L, XC is given as 1 upon omega C. So these are the some basic concept how we can approach the problem. Let's move further on our problem. In this problem, what is given? An AC voltage is applied to a resistance R, inductor L in series. So basically here, key inductor and resistor are given, right? If R and inductive reactance are both equal to 3 ohm, phase difference between the applied voltage and current. That is a very simple problem, because in this problem it is asked about the resistance and inductor, and both are connected in series. So we can see this is nothing but this is our LR circuit. Okay, one member is missing in the series LCR circuit. So if we draw the LR circuit, so we can say LR circuit is something like this, right? This is our LR circuit. So we can say the reactance of the across the inductor, that is the XL, and the resistance of the this resistor is the R. So here it is asked about that we have to find out the phase difference. Firstly, we have to write down what is resistance given in the problem, that is the 3 ohm. What is the reactance given, that is also 3 ohm, right? So here, if we want to draw the impedance triangle, then we can also find out the phase. So we can say this is our R, this is our XL. So this is basically our Z, that is the impedance, and this angle is phi. So here, in order to find out the phi, we can say if this is XL, so this is also 3 ohm, 3 ohm. So here tan phi, this can be written as perpendicular upon base, that 3 ohm divided over 3 ohm, this will equal to 1. So we can say our phi equal to nothing but pi by 4. So option A is the right one, right? So that is again very easy problem, and we can observe one thing in previous CBSE AIPMT 2006, 1996, the same type of problem is asked. The same type of problem is asked, and in this year also the similar type of concept is also happened. So we can say we have to understand the nature of generally which type of problem is asked in the examination, right? So here we can move the another problem. What is given in this diagram? The series LCR circuit is given, right? Here the voltage across L, the voltage across L, C and R is given. Voltage across, and what is the voltage given? That V1 and V2 each having reading 300 volt. So we can say V1, the voltage across inductor having 300 volt, and V2 is also 300 volt. That is also 300 volt. Correct. So we have to find out the reading to voltmeter V3. We have to find out the reading across the voltmeter. Right. So how we can find out the reading here? One thing we have to see here, VL equal to VC, and this is given at 300 volt, right? Not ohm, 300 volt. So we can say that this value signifies a lot. And what is meaning of VL equal to VC? If we say that if VL equal to VC, so this is the case of the resonance, right? This is the case of the resonance. So we can say if this is the case of resonance, so in this case, what we can conclude and we can say that is, if this is the case of the resonance, circuit is behaving like pure resistive circuit. In previous slide, I have discussed if this is the pure resistive circuit, it means Z equal to R. R equal to given at 100 ohms, we can find out the value of Z. If we find out the value of Z, we can also comment about the current. Current is nothing but voltage upon Z. So we can find out this value, right? So what is the value of voltage here, guys? So if we talk about the voltage here in this problem, sir, in this particular problem, if you want to calculate the voltage, we have to given V1 and V2, right? And this voltage is also given. Okay. So here, if we apply the formula that V net square equal to VR square plus VL minus VC whole square, and we know that VL and VC are equal to each other, then we can say V net equal to VR. Right. So we can say that the V net equal to VR. So here the net voltage is again equal to VR voltage across the resistance. We can take the value of V3 is nothing but that is the 220 volt. This value is equal to 220 volt. If we this value, so we can easily find out the current. What is the value of current? We can say that 220 divide over, we know the value of Z, that is the 100, and in this manner this value will become 2.2 ampere. So here we can say that what is the reading of the ammeter. So we can see our correct answer is option B, and that is again very good problem, right? So here in this manner we can say that we can approach. And how we can solve problem, we have to see one thing, we have to know what is the basic terminology of AC circuit, what is the reactance, what is the reactive, what is the inductive reactance, capacitive reactance, and what is the RMS current, what is the power factor. So these are the basic terminology. Now I am going to discuss one very important concept. By using this concept, you can solve any type of problem, right? So now I am going to, this is the basically a very practical method. We can solve a difficult problem in easier manner. Okay. So wherever we are going for our higher study, this method is basically give me idea how we can tackle with different approach. Maybe this type of approach is not mentioned in our syllabus, but using this approach we can solve any competitive level problem. So I am going to discuss this method. Let's see with the example, right? What I am going to discuss here is, suppose whenever a series LCR circuit is given, series LCR circuit, right? Suppose if series LCR circuit is given here, and if we consider, suppose if we consider a series LCR circuit, there is a AC voltage in this manner, and the voltage is something like V naught sine omega t, having some initial phase phi naught, right? This is the value of resistance R, XL, XC. Correct. What is the possibility and what is the variety of question asked in this segment? That is the C here. The very first problem, it is asked find the value of VRMS. Second, that is asked to find out the value of L, that is the inductance. Third problem, that find the value of C. Fourth problem, find the value of Z. Fifth problem, find the value of IRMS. Sixth problem, find the value of power factor. Find the value of power factor. Next, find the value of VR, voltage across resistance. Next, find the value of VL. Next, that find the value of VC. Next, find the value of VC, find the value of average power. Average power, or we can say power, that is the average. Okay. So these are the following possibility which can be asked in the given problem. Okay, so you can see that if we comfortable in the process, so we can solve any of one part in the given problem or all of the part whatever asked in the problem. Okay, so what we have to follow, what steps are involved to tackle this type of problem basically, right? If the voltage is given to us, right? So basically, how we can solve this type problem? Firstly, we have to take a assumption that this is our horizontal or real axis. This is our real axis, correct? And what we assume that this axis that already contain omega t. Okay, so this is the axis of the omega t. Whenever phi is given, we have to measure the angle phi with this axis, right? If positive angle is given, we have to measure the angle in anti-clockwise sense. And suppose if negative angle is given, then we have to measure the angle is clockwise sense. Correct. So here, what we can say that is suppose guys, here, firstly we have to find out the value of Z. We can say this is R. This is our XL minus XC. In this manner, we have to firstly find out the value of Z, then find out the value of phi, right? And we have to use a small step process and a notation. Whenever angle is written in this form, we can directly write down this angle in this manner, that V naught angle phi naught. What is the meaning of angle phi naught? That is the sine omega t plus phi naught, because we already mentioned we can measure the angle with omega t axis, right? So here, if we take one example, suppose if we take the value of phi, know the value of z, then how we can find out the value? That we can say value of phi is nothing but p by z, right? Here z is also make an angle phi. Z is also written in this manner, that Z equal to Z naught, and this angle is made from the omega t axis. This can be written as omega t plus phi. So in short, we can represent Z in this manner, that is Z and notation angle phi, correct. So if you want to find the value of I, we can put the value of V. This is the value of V naught angle phi naught. Again, we can put the value of Z naught angle phi, right? And here we are follow some basic rule. What is the basic rule? Whenever two angle is multiplied in this manner, angle phi 1, A into angle phi 1 and B into angle phi 2. So what we have to do? The constant term we have to directly multiply, and angle we have to plus. In angle we have to plus like the log. Suppose if given that A into angle phi 1 divide over B angle into phi 2. So this can be written as A by B, phi 1 minus phi 2. If we take one example here, suppose it is given that 3 sine omega t plus 60 degree into 2 sine omega t plus 0 degree, correct. If we multiply these two, to how we can write down this? We can write down this. This can be represented by notation omega t, omega t. We can take this is the reference axis. So in angle phi 1, we can put the 60 degree. So we can say 3 into angle 60 degree and 2 into angle 0 degree. Constant term we can directly multiply. This will become equal to 6. And angle, because the relationship between the angle is the addition, so we can multiplication, we can directly add. We can say this can be written as 60 plus 0, 6 into 60 degree, correct. And finally we can write down in the original format, that 6 sine omega t plus 60 degree. So this is the basic how we can write down the things. Okay, so let us move for the one problem. To take one problem, say here, this is our resistance, this is our inductor, and this is our capacitor, right? Here the voltage is given in this manner, and what is the value of given here? If we consider the our, this is our XL, this is our XC, okay, this is our R. If R is given as 2 ohm, XL is given as 9 ohm, and XC is given as 7 ohm, correct? And what is the voltage given here? That voltage is given here under root 2 sine 5t. Okay. In this problem, first part we have to calculate the what is the Z here. Second part, what is the I RMS. Third part, what is the VR. Fourth part, what is the VC, and fifth part, what is the VL. Right. Here we know that this can be written as, if you want to write down in the small notation, that V equal to root 2, and this is, we can say 0 degree, right? Here, if we calculate this in equation with the standard equation V naught sine omega t plus phi, that is the initial phase, to V naught, that is the peak voltage, is the root 2 volt, and value of omega, this can be written as the 5 radian per second. Correct. If we want to find out the value of Z here, so how we have to draw the impedance triangle, and we know that this can be written as R square plus XL minus XC whole square, square root. R square, this will become 2 square, XL minus XC, again, this will equal to 9 minus 7, that is the 2 square, and this will become 2 root 2. So this is the value of Z, right? If this is the value of Z, and we have to write down the equation of Z in the wave format. In order to write down this, we have to find out the tan phi. So we can say this is our R, this is our XL minus XC, and this is our angle phi, this is our Z. There, this value is equal to, again, 2. So tan phi is the 2 by 2. This value will become 1. So phi will become pi by 4. Correct. Value of phi equal to pi by 4. Right. So once we get the value of phi, we can write down the equation in this manner, that Z equal to Z naught sine. This is the base, and we can consider omega t here. Omega t, right? This is the positive. It means anti-clockwise. Pi by 4. Okay. And if you want to write down in our small notation, what is the small notation? Write down the magnitude of the impedance, that is the 2 root 2. Then see the what is angle of phase after omega t. So this is omega t, this is our reference, that is plus pi by 4. It means anti-clockwise pi by 4. We can say this is our pi by 4. I hope this is clear for you, everyone, clear to everyone how we can write this. Right. So again, if you want to write down what is the value of Z, so this is the equation of Z, right? In the magnitude, if you want to write down, that is the 2 root 2. If you want to find out the value of IRMS, in order to find out the IRMS, we can say that I, firstly we have to write down the I naught. Okay. And what is the value of I naught? We can say this is nothing but, if you want this value, firstly, I am not interested in IRMS too much. I also want to calculate I is a function of time. Okay, IRMS we can easily calculate because we know the magnitude of Z, we know the magnitude of V, that is the peak voltage, and we know the what is the value of impedance, we can directly calculate. But if you are interested, what is the I is the function of T? If we want to calculate what is the I as instantaneous current, I is the function of T. So how we can calculate? How we can calculate? We can write down in the next page that Z equal to upon 2 root 2 pi by 4. So if you want to write down the I, we can say V by Z. What is the value of V? This can be written as root 2, right? And this can be written as sine omega t, right? Here, what is the value of Z? Root 2 sine omega t plus pi by 4. But we know how we can tackle this type of scenario. We can say in the symbolic representation, we can write down this. This is nothing but 0 degree, 2 root 2. This is nothing but pi by 4. Again, we know that the constant term we can handle very easily root 2 upon 2 root 2 and angle. These are in the divide. We can also write down in the logarithmic manner, that is similar to a by b. Log a by b, that log a minus b. We can say that this can be written in this manner, angle 0 minus angle pi by 4. So this can be written as 1 by 2 and minus times of minus pi by 4. What is the meaning of minus here? The sense of angle is now going to be changed, and the angle from the omega t axis in the negative sense, we can say what is the meaning of negative sense? That is the clockwise, right? So if you want to write down this equation in the proper manner, we can say this is our maximum current, that is the peak current, 1 by 2 sine omega t. This is the minus, put minus sign here. That is the minus pi by 4. I hope this is clear for everyone. Right. Here, if somebody find out the value of the peak current, this is the 1 by 2. And if we have to calculate IRMS, we can also find out this value, that we know that I naught upon root 2. So this will become 1 upon 2 root. Correct. And then we have to put the unit, that is the ampere. Right. In this manner, we can calculate I. Once we calculate the value of I, we can find anything. Suppose if we have to find out the VR, we can say I into R. Okay, what is the value of I? We can write down this man 1 by 2 sine omega t minus pi by 4, in short form minus pi by 4. What is the value of resistance given here? That is the 2, right? And we know that this phase of resistance is also in the phase, that is the 0 degree. We can say this can be written as 1 by 2 into 2 minus pi by 4, and this will become 1 minus pi by 4, right? Okay. If we want to find out the VL here, that I into XL, what is the value of I? That is the 1 by 2 sine omega t minus pi by 4. And XL, the value of XL, we know that the XL is always leading in the phase. So we can say this value, we can say what is the value of XL given here, that is the 9. And this is leading in phase by 90 degrees. So we can say plus pi by 2. If you want to solve this, we can say this will become 9 to the 18, right? Here we have to see that this value, if you want to form the in terms of angle, we can say that this value is also written as sine omega t plus pi by 2. Correct. Here 1 by 2, these are the magnitude, and this is the minus pi by 4. We can say minus pi by 4, and there is the multiply relation plus pi by 2. Okay. If we solve this 1 by 18 and we're taking the LCM, so this will become pi by 4, right? So we can again say, if we write down in the proper manner, 1 by 18 sine omega t plus pi by 4. Put the value of omega, that is the 5. Okay, in the problem, value of omega is given at 5 radian per second. In similar manner, we can also calculate the value of AC. The value of AC we can also calculate, that AC is written as I into XC. Value of I we can directly write down 1 by 2, that minus angle of pi by 4. And XC we can say that XC that is lagging in phase. So we can say that if you want to write down the value of XC, The value magnitude is given as 7, right? And angle we can write down minus pi by 2. If we solve this, so this will become, actually here we have to see there are some calculation mistake. This will 9 by 2. This will become 9 by 2. So what we can say here, we can write down here, this will become 9 by 2. Here also we can write down this is 9 by 2, right? So this is, we can say that this is 9 by 2 here. So here this will become 7 by 2, right? And again, if we add this, so what is happening here, that minus pi by 4, minus pi by 2. If you taking the LCM here, this can be written as 7 by 2, and this will become minus 2 pi minus pi, that is the minus 3 pi by 4. If we want to write down in the proper manner, 7 by 2 sine omega t minus 3 pi by 4. Correct. So in this manner, we can find out any value once we calculate the value of current. Right. So guys, what we learn, once we calculate the value of current, we can find out the any value. So in this session, we learn what is the nature of the problem that is the previously asked basically in the net, okay, and what approach we should follow to attempt and solve any type of alternating current, okay, and basically we have to focus about the resonance condition, and if any general problem is given, then we have to follow the simple method, and firstly we have to write down all the data which are given and write down to apply the some basics of the alternating current, and in this manner we can solve any type of problem. So I hope you enjoy the session. Thank you so much.